Okay, this problem we're going to look at a gas law problem, and let me read it to you. It says the following reaction, this reaction here, 4 moles. Now this is going to be very important. You really have to understand the concept of moles. This says 4 moles in the gaseous state of ammonia plus 5 moles of oxygen yields 4 moles of nitrogen monoxide gaseous plus 6 moles of H2O gaseous. Does that come out on the... Yes, it does. Excellent. So, the question is this. All right, now, I have a sealed container, so it's going to be constant volume. So the volume is going to be 40 liters. Okay, volume, I'll write right here, volume 40 liters. Okay, what else is given? And it says the temperature is going to be at 120 degrees Celsius. And what do you automatically change that to? What is it? Kelvin. And what would that be in Kelvin? Yeah, so do it. 393. 393. Okay, good, excellent. Now, it says when 34 grams of ammonia reacts with 96 grams of oxygen. 34 grams of this, 96 grams of this. So right away, what kind of stoichiometric equation is this going to be? This is the stoichiometric equation, but what kind of stoichiometric problem is it going to be? It starts with an L. Do you remember? We haven't reviewed chapter 12. I did that purposely. I want to work backwards with the most recent material. So by the time we get to the old material, it'll be more fresh. Yes? Because it's so much tied into the new material. Limiting reagent, do you remember that? What's the limiting reagent? Okay. So it says when 34 grams of ammonia, NH3, reacts with 96 grams of oxygen, O2, what is the partial pressure of the nitrogen monoxide in the sealed container? So in other words, I need to know the partial pressure of that, correct? Now, I'm given mass, right? So if you have a problem, if you have a gas law problem, and you're working with a mass of something, what type of relationship are you going to have to use? Any ideas? Or Boyle's law, Charles' law, Gay-Lussac's law, combined gas law, Graham's law, trying to get you to go through it in your head. What might you use? We have masses, moles, volumes, temperature. They want to know pressure. They want to know the pressure. So what do you think we're going to use? Any ideas? Well, what about this equation? PV equals nRT. PV equals grams over gram molecular weight, right? 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 So here's my grams and moles and blah, 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 blah. So isn't that going to be the one we use, the relationship we use? And it is. This is kind of an ideal gas equation. And how else can you determine that? You're not given 2 sets of conditions. You're only given 1 set of conditions, right? You're not saying, well, here's a set of conditions. Now let's compare the set of conditions with STP. Let's compare the set of conditions at, say, 500 Kelvin and some enormous volume with standard temperature and pressure. You don't need to, right? Right? You don't need to. So there's no double sets of condition, yes? So we know that it's, all right, now, what's going to be the limiting reagent, right? How many moles is 34 grams? How many moles of ammonia is that? Have you thought about that? How many moles of ammonia? 1 mole? Really? 1 mole of ammonia is 34 grams? What's 1 mole of ammonia? I want you to think. I want, you know, this is, can I remind everyone of something? Can I remind everyone of something? I'm going to sound like a nagging parent. Can you try to remember, you've been in here for 10 months. There are certain things you should be able to see, like that. How many moles of ammonia is 34 grams? Haley? 17. You weren't paying attention. You were reading. Listen to the question. I asked you, how many moles is 34 grams? You said 17 because you thought I said, what's the mass of 1 mole? And I didn't say that. This is the brightest student in the class.
Thank you.
Yeah. 2, right? 2 moles, right? Yeah. 1 mole is 17. Remember we worked with, when we did stoichiometry, we did this. Remember we did that? Yes? That was 34, 28, and 6. Remember we did that? Ad infinitum? Yes? So yeah, so 34 should sound familiar to you. All right? So this is going to be 2 moles. Right? How many moles of this, therefore, am I going to need? If I have, not 4 moles, I want to use 2 moles. 2 moles of this, I must use 2.5, right? 2.5 moles, right? How much of this? 2 moles, right? And then, what's this? This is 3 moles, right? Okay, 96 grams. How many moles is that? 96 grams. You can do this. You can do this. You can do this. You can do this. How many moles is 96 grams of oxygen? Sultan, you're looking at me like I'm the ref at a tennis match and you're waiting in very bored way for the tennis match to begin. What's the mass of 1 mole? Of oxygen, O2. What's the mass of 1 mole? 12? Is that what you, did somebody actually just say 12? 16? O2? O2! O2! 32, right? 32. 32 grams is 1 mole. How many grams do I have there?
3.
I have 3 moles. I have 96 grams. 96 divided by 32 is... Are we keeping you up? Oh. You should see the way she's looking at me. Wow. Good look. Right? Yes or no? 3 moles, right? But how many do I need? How many do I need? How many do I need? I need 2.5. So how much am I going to have in excess? Half a mole. 1/2 a mole excess. That's going to become very important. Yes or no? Is it going to become very important? It will become very important. Now it says, listen to the question. When 34 grams of ammonia reacts with 96 grams of O2, what is the partial pressure of the NO? Can we answer the problem yet? Can we? We can't? How many moles of this am I creating? 2 moles. Let's look at the equation. PV, here it is right here. I'm looking for P. Do I have V?
Yeah.
What's V? You said we have V. What's V? He's pointing to a giant white board. Like I can see that. 40. Yeah, you can just say it. 40. 40 liters, right? What's N? What's N? What is N? They're stunned. Let me read the problem again. It says, when 34 grams of ammonia reacts with 96 grams of oxygen, what is the partial pressure of nitrogen monoxide in the sealed container? How many moles of nitrogen monoxide am I creating? How many moles? The answer is right on the board. Have you counted to 2 yet?
Yeah.
Excellent. Excellent. He's counted to 2. Excellent. It's 2 moles, right? Because I have 2 moles of this, 34 grams, I have 2 moles of this. Do you understand that? 2 moles of this, so it's half of that. So 2.5 moles of this, 2 moles of this, 3 moles of this. Yes or no? Yes or no? Okay, good. So can I say, I'm looking for P, right? Can I say P equals, can you see the green? Shall I get another color? All right, can I say P equals what? P, well, that looks good. P equals what times what times what divided by what? nRT, right? Over what? Over V. All right? Are you with me?
Yeah.
Okay, do you have your calculators out?
I got you.
Excellent. Excellent. Now, so P equals N. What's N? 2. Excellent. Can I leave off the unit labels? Yeah, as long as everything is, I'm going to calculate in terms of what? What's pressure? Pressure is kilopascals. Volume is what? Liters. N is moles. Temperature is, what is it? Kelvin, right? Okay, so what? So 2 times 8.31, that's going to be R, 8.31. I made a video to show you how you can actually calculate that number if you forget. It's on your sheet though, isn't it? I think it's on there somewhere. Okay, times what?
Yeah, it is.
It is, right? Yeah. Times what? 393, right? Over what?
Over 40.
Right. Okay, so mash that out. Come on. On your calculator. Anna, you with me? Excellent, girl. Excellent, excellent, excellent. Abdullah, did you do it already? You did it? What did you get?
160.
160? Is that what you said? 160?
That is not correct.
Did you say 160? Anna, what do you get? 163.3.
Yep.
Did you round that, Abdullah? I think you took a few liberties with that rounding. Do it again, Abdullah. Is that right? 163.3?
Yeah.
Andrew, please make sure that the young man gets it correct. Okay? Are you with me? Yes or no? That's the partial pressure produced in the can. Okay? That's the partial pressure produced. Yes? 163.3. That's what that says, partial pressure. Okay? Can you read that? Perfect. Perfect. Excellent. Yes or no? Are we okay with that? Yes? Okay. Then it says, what is the total pressure of the container? Can I erase this now? Can I erase this? Can I erase this? Is that all right? We can use the same problem, but I want to know the total pressure. All right? I'll help you do this, right? Right? Sultan, are you with us?
Yeah.
Excellent. I'll help you, okay? The pressure total is going to be equal to 8.31 is R. T is going to be 393. And V, remember, it's a closed container, rigid container. The volume is constant, that's 40. What's the number of moles that I produce? What's the total number of moles I produce? What's the total number of moles? What's N going to be? What's N going to be? Martha, any idea? Well, let's review what I have. Normally this would be 4 to 5 to 4 to 6, right? Yes? But I have 2 moles. 2 to 2.5 to 2 to 3. Are you okay with that? So what's the total number of moles that's being produced? You can add, right? Anna, what do you think? 5. You knew that though, right? Could you help me out and not leave me hanging, okay? Be like, give me a high five and I'm like left hanging, can you like help me out here, please? She's one of the brightest students in the class. She's like leaving me hanging, okay? Thank you. So 5 is the answer. I put N is 5. Did you get like the Nice Person of the Year award today, Agustina? I mean, you got so many awards. You got 2. That was a lot. I didn't get any. So what is 5 the answer? Is N 5? Fatima? What is it? 1?
I didn't say anything.
Well, that's part of the problem. What's the total number of moles that I produce? 5? TJ, is that what you think?
Yeah.
5? But don't I have a half a mole left over here?
5.
Isn't that in the can?
Yeah.
Yeah. Don't I have a half a mole of oxygen left over in the can?
5.5.
Right. You get it?
Yeah.
You get it? Augustina's looking, out of the confusion comes knowledge. If that's a true statement, she's about ready to understand because she looks very confused. Are you with me? Okay, look. This is the total pressure. So the total number of moles, according to this equation, is going to be important to influence this pressure. Wouldn't you say that's true? Wouldn't you say that the volume is 40? That's easy. That's right. The volume is 40. That the temperature is going to be 393. That's given. This is R, right? So I'm left with the moles, right? So I need the total number of moles. I need the total number of moles in that can after the reaction takes place. You can't do that? Isn't this, it's almost too easy, right? I know what you're saying. I did this problem for somebody after the gas law test and they said, what? That was their first reaction. Like, wait a second, that was easy. Right? Isn't that what you're saying? There's something too easy about this? Well, it is easy. That's what you get 34 grams. That makes it easy. because 34 grams is 2 moles. So I'm going to start with 2 moles. So we need 2.5 moles of this. I need 3 moles. I'm going to get 2 moles of this and 3 moles of this. So that's 5 moles. But I'm given 3 moles of oxygen, not 2.5 moles. So I have 1/2 a mole in excess. So the total number of moles in that can after the reaction, the total number of moles, 5 moles plus the 1/2 that's in excess. Never reacted, it's still there. So this is going to be 5.5. So run that through, run those numbers through, crunch them out. What do you got? The tension is getting very thick in here. I'm being sarcastic. If the tension were any less, you'd all succumb to low blood pressure.
448.5.
What is it?
448.5.
I can't hear you, hon.
448.5.
448.5 kilopascals. Do we have another one that, somebody else that got that?
I got 449.
You got 4, well, same.
0.1.
All right. But that's close. Is that good? Okay. You get it? Yes or no? It's actually not too hard. This is key right here. The number of moles that you're. Yes? Get it? Okay. All right. We're off. Was that the second problem or the third or the first problem? That was the first one we did? Okay. Let me just make sure that you can all see this. Bring that down a little bit like that. Alrighty. That looks good. Let me bring it down a little more. I think it's all set on the right. Okay. All right. You have it down? Everyone have it down? You okay? All right.